So this is your lecture video for section 5.5, fractions, decimals, and order of operations. In this section, we're definitely going to need a calculator, so take a minute, go grab one. Remember that for the final exam, you will be allowed to use a basic calculator, so a scientific calculator or below, so no graphing calculators will be allowed. Converting fractions to decimals. To convert any fraction to a decimal, simply blank the numerator by the denominator. Divide. Whoops. For example, if here we have several fractions, if we want to put these in decimal form, just grab your calculator the way we say this is the way it gets typed into the calculator. So 1 divided by 4, and your calculator will tell you 0.25. 12 divided by 25, 0.48. Negative 19 divided by 500. Again, all of these are going straight into the calculator. There we go. I'm not going to go through the rest of these. It is just calculator usage. Let's see if anything different comes up. Let's keep going. Converting mixed numbers to a decimal. To convert a mixed number into a decimal, the whole number part of the mixed number stays the whole number part of the new number, and the decimal part is the fraction. So if we have 7 and 5/8, if we want to write this as a decimal, that 7 is the whole number, so that's to the left of the decimal, and then the 5/8, we would do 5 divided by 8 and get 0.625. So 7 and 5/8 is the same thing as 7.625. The next one, negative 208 is the whole number part, so that's to the left of the decimal, and then 9 divided by 20 is 0.45. And let's do a couple, we'll do these. So negative 72 is the whole number part. 11 divided by 16 is 0.6875. I'm just checking if it said anything about rounding. It did not, so we'll write out that whole decimal. This would be 5, and 36 divided by 40 is 0.9, so 5.9. Repeating decimals. When fractions are converted to decimals, sometimes the decimal doesn't end, it just repeats. For example, 1/3, if you check that out on your calculator, 1 divided by 3 is 0.3 and it doesn't end. So a way to show that is to say this notation, 0.3 with a line over it. That line over the digit it indicates that that digit repeats. So let's check these out. For example, so we know from above that 4 is the whole number part. When we do 7 divided by 9, there's the digit 7 that repeats, so that 7 would get a line over it. Negative 45 divided by 22, there's a whole number part, so negative 2 point, you see how it's 0, 4, 5, 4, 5, 4, 5. The digits that repeat is the 4, 5. So that we would want, we're not doing that, right? That's not the 0 that repeats. It's just the 4, 5 that repeats. So I'm just going to erase these, and we would write it like this. Negative 2.0, the line is over the 4, 5 because that's what repeats. Let's say negative, and then 58 divided by 111 is 0.522. It's the 522 that repeats. If you're noticing that over here your calculator has a 3, your calculator is just rounding that last digit because your calculator can't show all the digits. It's going to round it at some point. 9 and 7 divided by 12 is 0.583. It's only the 3 that repeats, so it's just the 3 that gets the line on top. Using what we've learned about converting fractions to decimals in rounding, let's answer the following. So now we're converting fraction to decimal and we're rounding to certain place values. So 3 divided by 11 is 0.27 repeating. But if we're rounding to the 10th place, I'm going to underline the 10th place, look at the digit to the right, and so this would round to 0.3. 2 divided by 7 is 0.27. 28571. So this one just goes on and on. If we're rounding to the thousandths, here's the tenths, hundredths, thousandths. If I look to the digit to the right, that would round up to 6. 9/13 is 0.692307 and so on. Here's the tenths, hundredths place. If I look to the digit to the right, it's not 5 or bigger, so the 9 just stays 9. The next one, -11 divided by 19 is negative 0.578947. We're going to the 10,000. So here's tenths, hundredths, thousandths, 10,000ths. So that 9 stays a 9 because 4 is not 5 or bigger. All right, insert the appropriate symbol. So on the left side, we have 0.5. On the right side, it's 0.5 repeating, which means this, so that one is bigger. So 0.5 is less than 0.5 repeating. -4, I'm going to convert that, -4.25 and -4.252525. And because, remember on the number line, when we're dealing with negative numbers, -4.25 would be here, -4.252525 would be over here a little bit, so that one's further to the left. So this one is the greater number. Order of operations with decimals. When working with decimals, you apply the same rules as our order of operations. So let's just remind ourselves what our order of operation rules are. Parentheses or any grouping symbol, exponents, multiplying and dividing left to right, and then adding and subtracting left to right. So when we look at this first expression, we do have a set of parentheses, so this operation will happen first. And I'm doing that on a calculator, 10.42 minus 7.52. So recopying and just replacing inside this parenthesis what we just calculated. Exponents would be next, so 2.9 squared. This negative, just noting, that's outside of the parentheses, so it's just the 2.9 that's being squared. So what I'm typing into the calculator is 2.9 times 2.9, which is 8.41. The parentheses, if you had them there, that's okay. They're no longer needed because there's nothing to do inside the parentheses and the squaring is done. So I'm going to get rid of those. And then it's just the subtraction. So 11.38 minus 8.41 is 2.97. So all of these expressions were equivalent, and we stop when we get the most simplified expression. Next one we have looks like a couple set of parentheses. I'm going to color code these just to help my eyes see them. So we've got these go together. Okay. So we start at the innermost parentheses. So 16.7 minus 6.5 is 10.2. And I'm going to copy everything else. I'm not calculating anything else, one thing at a time, just to make sure we follow the order of operations. Next would be looking in these brackets, another grouping symbol. We have a division and a multiplication, so we'll work that left to right. So 10.2 divided by 5.1 is 2. And I'm just recopying. Still in that grouping symbol, so 2 times 3.4 is 6.8. So 10.91 minus 2.1, there's an understood multiply connecting that 2.1 to the 6.8. So we have a subtraction and a multiplication. That multiplication will happen next, 6.8 times a 2.1. So we have 10.91 minus 14.28 is a negative 3.37. Again, all of these expressions are equivalent. We are done when we get to the most simplified expression. Evaluate the expression for the given values. Evaluate, that means you are plugging a value in for a variable. So we have an expression, I'm going to write this just a little bit bigger. 4/3 times pi times r cubed. Pi is a symbol that is used for the number 3.14. Actually, there's more to that number. It's, yeah, we'll just call it 3.14. Just know that there's more to that number. We shorthand it there. Let's see. If R is 3, so actually substituting a couple things in. Instead of pi, I'm going to write in 3.14. And instead of R, I'm going to put in 3. So let me highlight just a couple things. This 3 is this 3. It's the cubed. And this 3 is because it said put 3 in for the R. So now we follow our order of operations. Exponents would happen first. So we'd have 4/3 times 3.14 times 3 times 3 times 3 is 27. Now it's all connected by multiplication. So I'm going to stick all of that into the calculator. So 4/3, and you could do 4 divided by 3 and then times 3.14 times 27. And it should be 113.04. All of these expressions were equivalent. We stop at the most simplified one. So 113.04. Applications. A night at a hotel in Dallas costs $185.95 with a nightly room tax of $24.17. If John stays for 5 nights, how much is his total bill? Okay, so we have a cost of $185.95 plus the tax, and we'll add that together, but then we're going to multiply that by 5 because we're staying 5 nights. So order of operations, let's add these together. First, 185.95 plus 24.17. So each night is $210.12 times 5 nights would be $1,050.60. And us putting that is telling us what units we're in. I'm just double checking one thing. It does say a nightly tax. It wasn't just the ending amount 1 times tax. It's that times 5. So, yep, we did that right. Oh, and that's your section. One couple things I want to remind you of. When you're doing order of operations and you're in the middle of a problem, I got a couple questions on this during some tutoring hours and just in an email. So let me just make sure we're good there. This first one means the negative gets included with the squaring. The second one means the negative is sitting out in front and it's just the 2 that gets squared. So that would be -4, but over here, this would be +4. And I'll work just one more example. If we have -3 squared versus -3 in parentheses squared, this first one would be negative and then 3 times 3, so that would be -9. The second one is -3 times itself, -3, which would be +9. Keep the questions coming. Y'all are doing good asking when you need help. Keep that coming, and remember that you can text at any time, and office hours on Monday morning. Hope to see you then. Good luck to you on your ALEKS homework section, and I'll be talking to you soon.